Question 1 says, multiply 3.4 times 10 to power minus 5 by 7.1 times 10 to power 8 and leave the answer in standard form. So how we go about this is 3.4 times 10 to power minus 5 times 7.1 times 10 to power 8. We can multiply these two decimal numbers together, which is 3.4 times 7.1 times these two indices, 10 to power minus 5 times 10 to power 8. When we multiply these two, we'll get 24.14 times. From laws of indices, when you multiply two numbers with the same base, you add their powers. So this will be 10 to power minus 5 plus 8. And so we'll have 24.14 times 10 to power 8 minus 5 is 3. And if we shift this decimal point to the left 1 times, the power increases. So we have 2.414 times 10 to power 4. That's the answer. 2 says, given that P is those set of P such that P is greater than 1 and less than 20 strictly. So P starts from 2 to 19, where P is an integer and arrow are those set of arrows such that arrow is greater than or equal to 0 and less than or equal to 25, where arrow is a multiple of 4. Find P intersection arrow. This is under set theory. The first thing you want to do is to list out what P is. So P are those numbers from 2 to 19. And R are those numbers from 0 to 25 that are divisible by 4. That's the meaning of multiple of 4. Those numbers 4 can divide from 0 to 25. It starts from 0 to 4 to 8 to 12 to 16 to 20, 24. Now, P intersection arrow simply means the intersection of P and arrow, which are those numbers you can find in both P and arrow. They are 4, 8, 12, 16. That's all. We can find 20 here. We cannot find 20. So it will be 4, 8, 12, 16. That's all. 3 says the first term of an arithmetic progression is 2 and the last term is 29. If the common difference is 3, how many terms are in the AP? You recall the formula for AP, which is the same thing as the last term. Last term is same thing as the nth term of an AP is A plus n minus 1 D. And in this case, our A is 2. We're looking for n, and our common difference is 3. And we are giving the last term as 29. I can subtract 2 from both sides. 29 minus 2 will give me 27. We'll have n minus 1 by 3. Can divide both sides by 3. So that I have 9 equals n minus 1. Can add 1 to both sides so that I will have n to be 10. So there are 10 terms in this arithmetic progression. Question 4 says, express in index form log s to base a plus log y to base a equals 3. Remember from the laws of logarithm, if we have log xy to base m, this is same as the log of x to base m plus log of y to base m. And so you can easily take from the right to the left and from the left to the right. These are laws. And also for us to convert a logarithm to an index form, if we have log x to base a equals b, it will be x will be a to power b, a to power b. So we'll be using these two laws here. And so this will be log x y to base a equals 3. Now, how do we convert this to index form? It will be xy have to equal a to power 3, and this is the answer. So likewise, we can convert this back to this by taking the log to base a of both sides.